Hey, welcome back, everyone. This is Chase, and joining me today, two guests, Kris Romig, Commercialization's Services Lead at NASA Johnson Space Center, and Dr. Julie Lamarra, a faculty member here in OPDD. Thanks for joining me.
Yeah, glad to be here.
Wanted to have you both on because you both wrapped up an incredible project in one of our classes, Julie, in one of your classes in particular. And wanted to do a little debrief and just kind of get your thoughts on how you both felt like it went. It was a pretty unique project, and we'll get into some of that today. But Kris, do you mind just sharing a little bit about your role with NASA in particular? I think that'll help set the stage for what the project ended up being.
Yeah, sure, Chase. So my role at NASA is really I am the Commercialization Services Lead or Technology Transfer Officer at NASA's Johnson Space Center. Myself and my team are responsible for really being custodians of all the intellectual property, the inventions, innovations, software development that comes out of the human spaceflight program at Johnson Space Center. And the goal of the tech transfer program across the agency is to get NASA's technology broadly out into the world as much as we can. So we do that through a lot of different mechanisms, through things like licensing agreements, working with academic institutions, giving students access to NASA technologies to do the very things that Dr. Lamarra and her class was doing this semester. So that's broadly it, is get NASA tech out into the world.
That's great. What types of technologies are we talking about? We'll get into the specific ones used in this project, but what's the breadth of materials and technologies that you're dealing with?
Yeah, so we have them divided into 15 separate technical categories, ranging from materials and coatings to robotic systems, rocket engine technology, aircraft technology, computer software. You name it, pretty much. If NASA's working on that kind of tech, we've got it broadly available for everybody.
That's great. So that's where some people might think, okay, rocket technology, outdoor product design, where's the connection? I think we'll get into what materials crossed over here in a little bit, but Julie, do you mind sharing a little bit about your class, design thinking, and how you wanted to incorporate a real world project into the class?
Right. So I taught design thinking for our juniors in our program. And design thinking is really a methodology that students and people go through when thinking about how they're going to kind of approach or come to a solution for a design problem. And I taught a human-centered approach to design, which is all about finding out who the person is that this design is going to be made for, what are their pain points, what are the things that they need to do to achieve pure comfort or accessibility into the realm in which they are going to be using this product in. And I pair that along with an activity-centered approach, because when we're thinking about the outdoor product world, we're thinking about designing products that can give access to sport in the outdoors. So that means that the people that are using these things not only have to be safe, they have to be comfortable, and they have to have the ergonomic capability to do the activity in which they are seeking. So it's really a research-based approach to design. And it doesn't take a very linear process, even though the process seems very linear when you start with empathy and then you define down the problem statement, then you start ideating and prototyping and testing. It all kind of gets mushed around and moves kind of in a non-linear space, and it always comes back to the human. It always comes back to the human doing the activity and what really needs to be solved within that space. So I gave them a challenge, and it was a really big challenge, and it was difficult for students initially to kind of wrap their heads around making a product for the outdoors and then infusing that product with a NASA tech. So the challenge was simple. It was find a problem in the outdoors where people need innovation in a sport of some sort. You can pick whatever that is, and infuse this NASA tech into this product to make it innovative, to make it accessible, and then also thinking about, you know, affordability, feasibility. They didn't have their hands on the actual items or the materials, but they were really able to get a deep dive with these patents and finding out, like, what are the capabilities of these materials? What are the specs of these materials? How much do they weigh? A lot of students actually focused on like ultralight activities. And so they were digging really deep into the specs of these items to make sure that they were within those ranges for ultralight specifications. And they had their patents out, they had a dictionary out, they were really just deep into understanding what this tech is, what it's capable of, and then how can it be beneficial in an outdoor recreational space where humans are involved and activity is also involved. So it was a really awesome project, and I'm so glad that we did it, because even though it was very, very difficult for students to wrap their head around it, when they finished, there was just this sense of accomplishment and joy that went along with it. And I do believe that they really did create something innovative, in the pure sense of innovation, where this was new, this was exciting, and it solved a problem.
How did you determine which materials you would present or make available for the students? Kris, I know NASA has hundreds, thousands of potential materials and technologies to use, not all of them directly applicable to outdoor products and sport. How did you two work together to figure out which ones would make most sense? I know, Julie, you kind of went through an initial vetting and identified things that you thought would make most sense. But what did you end up on deciding, and then which materials, or how did the students select the material they wanted to use?
So Kris gave me an initial list. It was a pretty extensive list of portfolio of PDFs that I poured over. And then I kind of curated down from there. But when I presented these materials to the students, I let them know, I'm like, this is not a comprehensive list. I didn't want to overwhelm them with like the whole entire portfolio that they did have access to. So students were able to go through that list and then start to brainstorm on like, what could this be used in? What is this actually for? So their process actually started with understanding what materials were actually going to be available to them first. And then they started kind of going backwards and trying to find a space in the outdoor industry where these could be implemented in. So like I said before, it's a non-linear process. It doesn't matter where you actually start. The process involves going back around to the human-centered needs or the activity-centered needs within the project. What ended up happening with a couple of students is that they're like, I don't want to use just one product. I think that this project that I'm working on is going to need 3. Can I use 3? And I'm like, sure, go ahead, use 3. Research 3 products. A few other groups that worked together decided that nothing that I had curated was going to meet the needs that they were looking for. So they went and took it upon themselves to take a deep dive into the larger portfolio of NASA and found some materials that I'm like, even Kris and I both kind of missed that worked wonderfully for their projects. So it was a little bit more open-ended in that sense that I didn't give them a specific thing that they had to use and they had to implement in a specific way. It was more, here are the things that I think will work well for this project. You may choose these. If these do not meet your needs, do not feel that you are beholden to this small space. You can kind of go above and beyond, and you can go into a deeper dive, which actually a few groups ended up doing successfully.
That's great. Kris, I know NASA initially approached the university to explore partnership opportunities. This is something that you've done in the past with other institutions. What intrigues you or is interesting to you about working with students on projects like this? Like, why do this? This is one more thing that you have to worry about. You've got a day job. Like, what is it about connecting with students and I guess connecting with our program in particular that was interesting?
Yeah, no, it's a good question, Chase. And there's a number of answers, really. For me personally, I've gone through my own academic programs, coming up through getting my bachelor's degree and master's degree, and always appreciated that connection with industry, even if it was something that I wasn't particularly interested in going and pursuing a job, and just getting that real world practical application was always more inspiring or motivating sometimes than just the pure lecture side of my academic career. So that in and of itself is kind of a wanting to participate at that level. The other part of it too is really just trying to give some educational opportunities using NASA technology to students is just a great thing to give them an opportunity to grow, to evolve, to look at NASA tech in a different way. Maybe even give them some internship opportunities, right? So making these connections at the university level, there's a very strong perspective around creating a pipeline of new employees for the agency, talented, inspiring, creative individuals who want to come work in the space program. And so staying connected to academic institutions is one way that we do that. And that's always a great thing because you find talent in all these different programs across the country and different academic institutions and ways to make those connections to say, hey, have you actually ever thought about a career at NASA? And it may not be something you were doing specifically for your program, but there are opportunities. Let's look at that. Maybe there's some internship opportunities that would be available. So, that in and of itself is cool. Just kind of giving some opportunities to students who maybe didn't think that they would ever be able to work for the U.S. space program. And if that's inspiring to a student or a team of students, then that's a huge win for both me personally, right? Fills me up, but it also is a win for the agency. And honestly, the other part, which I think is just the coolest thing, is just the inspiring creative projects that the students come up with. Taking technology that was originally developed for aircraft or spacecraft or living and working in space, and seeing students like the OPDD students from last week when we had the kind of exit briefings come up with some brilliant product ideas based on NASA tech, and maybe has nothing to do with the space program, but it was just super cool and very inspiring to see that creativity and very practical applications of these space-based technologies for markets here on Earth. So that is just a really cool thing. And so, yeah, that just keeps me pumping and wanting to keep doing this type of work because it's fascinating to see that creativity.
How does NASA commercialization typically work? Do you usually have a company that's approaching you and says, "We've been looking through your portfolio and we'd really like to take this technology or material and see if we could integrate it into what we're doing"? How does that typically work outside of this project? What does your day to day look like in that regard, and how are companies interacting with you to use your technologies?
Yeah, no, day to day, my days are all over the place depending on what's going on. But more often than not, it is a private company coming to us saying, "Hey, we've looked through your patent portfolio. We've got a little over 1,400 active patents across the agency in those 15 different domains I was telling you." So they'll be looking for a technology to solve a problem or create a new product or service, depending on what they have going on. They'll reach out to us. We have a concierge that helps them, guide to the right NASA field center based on where the technology is from. It's not always easy to understand if you're just looking at the website, technology.nasa.gov, right? Yeah, it's just a lot of tech. And so, but each specific field center where the inventors are, right, will have more information and more, just more technical information about that technology. So they'll reach out to us. That's a lot of the interaction. We have licensing managers. If the company is interested in licensing that technology for commercial applications, then we'll go through that process. Sometimes it's just a partnership opportunity or a collaboration or co-development opportunity where there's just mutual interest in a technical area. And, our technical folks on the NASA side want to work with the outside entity and, kind of combine resources and continue to mature the technology. So that happens from time to time. And then the other part that we're starting to get into is working with incubators and accelerators. So it's less one-to-one company to NASA technology and more working with an organization who's already got a large network of startups, entrepreneurs who are looking to either start a new company or bolster their current product offerings, right? And then that incubator or accelerator will be that connect to the NASA portfolio. So we'll have that relationship with them. They'll say, hey, we're going to do a cohort looking at clean energy, right, or agriculture. And so much like what we did, with you all, we kind of take the list of technologies available and cull it down to what's relevant for that particular cohort as best as we can, right? And we miss things all the time because we don't always know the end application. And so, then we'll work with those incubators or accelerators, and they'll do all the cohort work. They'll do all the pulling entrepreneurs together. And so that tends to be a better fit for us, is from not a lot of resources on the NASA side doing this work, but if we've got someone with a broad network in the community or within the entrepreneurship community, then they can really help supercharge that. So it's not very different actually than what we did with you all at Utah State, right? Which is, you've got a cohort of students in a class where Julie, you've already looked at the portfolio of tech, you've kind of skinnied it down to something that's relevant, and then you ran the actual program for the semester. And that works really well. It helps us expose the most people as possible to NASA technology. And it's really not a sales gimmick, right? The whole point is to let people know, to create awareness around that NASA is accessible, right? The technologies are accessible. The inventors at times can be accessible. The unique facilities that we have can be accessible. And so breaking down those barriers to say, hey, it's your space program. How do you want to participate? And these are some great ways to get started with that. So day to day, it's a broad range of different activities and organizations that I engage with, but that's typically what it looks like.
Yeah, I asked a little bit about how you engage with industry, because I think a result of this, I'm jumping a little ahead to some of the results, but I know we talked about plugging in an innovation team into the final presentations. And I don't know, I haven't gotten permission, so I don't know if I could say which company we got involved, but safe to say a large sporting goods company participated in that. They brought their innovation team and their innovation designers to hear the final presentations. And I think one of the things that we wanted to do to connect the dots and hopefully see some of these projects become a reality was bring in a potential corporate partner that might want to see some of these projects through, similar to what you're already doing day to day, is maybe facilitate something like that, or help an innovation team recognize, wow, NASA is accessible. Like, why aren't we doing this if we're not already? And so I hope that we accomplish that. I think it's still early days, and there's some potential opportunity to maybe see some projects go a little further beyond just the final presentation. So I think certainly more to come there. But I think in future iterations of this, I think we all agree we'd like to see this happen again. I think there's even more opportunity to connect the dots and maybe even see some of these projects go a step further beyond a final presentation, and maybe connect with a company that could see it through. So definitely something that we have aspirations for. I guess I shouldn't speak for you, Julie, but is that something that you're interested in, is like seeing these students or connect them to an opportunity that could become more of a reality?
I'm definitely on the same page as you, Chase. We've had that conversation plenty of times. I really want to give my students real world experience that's going to propel them into the industry, not only as just cogs in the wheel, but as leaders of innovation and of sustainability, and of having a purpose of making more things in the world. Because as we all know, there are a million backpacks out in the world. Why do I need this one that you have made? What makes it special? What is the thing that sets it apart from the group? And I push my students to really think about those real world applications. Is it feasible? Is it sustainable? Is it durable? Is it all of these things that kind of come up? And are you adding more to the problem, or are you actually solving a problem? And so we talk a lot about wicked problems, and how these ideas of you're trying to solve one problem, but you've actually created another problem on the back end. And that as a leader in this industry, you should never be working in isolation. You should never be working alone. And only the collaborative efforts across all the domains of interest are going to really propel these innovative ideas and really push the boundaries of what is going to be created in this world. And so having this kind of trifecta of collaboration happening in this class opened their eyes to seeing like, yeah, this is real. Like, we need to talk to these other people. We need to start connecting the dots across these domains of interest. And I also had them work in groups, so it wasn't an isolated event either in that respect. And so having our students do these things and then connect with outside entities really pushes that idea that what they're doing matters, and it's not just for a grade. It is for getting their ideas out into the world. It is for propelling innovation. It's for propelling thought. And they have some really amazing ideas. And some of them don't give themselves enough credit on how absolutely amazing their ideas are until they get that external feedback. And then that propels them even further to go, hey, I'm on to something. Maybe I can push it further. And so if we can make those connections, or at least make those initial connections, and then show them the open door that's right there for them to walk through, my hope is that there's going to be some students that are going to take those opportunities and move forward and really do something that's meaningful in this industry beyond just making more things to make more things.
Well, hopefully students listen to this because we're just going to shower them with praise, of course. But do you want to talk a little bit about just kind of what they were going through, their thought process? You were there with them throughout the
Yeah.
whole experience. You saw the terror in their eyes.
Yeah.
You saw the excitement at the end of it. I mean, you and I talked about how when you said, "Oh, we're going to work with NASA," they all stood up, sat up straighter in their chairs. Like, can you talk about just what they went through from your perspective?
Yeah, so I didn't actually disclose that we were going to be working with NASA or our other industry partner until we got right up to when we gave out the assignment. So the first half of the semester, we're exploring the design thinking process and this nonlinear approach to design, and talking about what is human-centered design, what is activity-centered design, what is creative thinking. We pour over text and design sprints, and we just kind of get their feet wet in this process. And then all of a sudden things got a little bit real for them when I'm like, by the way, we have this opportunity to work with NASA. We also have this opportunity to kind of bring forth these techs into this space, and we're going to be using this design methodology of design thinking and these different approaches to design. And it is something totally different than what they're used to doing. They're used to, finding a problem, getting a solution, and then prototyping the heck out of it, and just getting their hands dirty and wet and just testing and going until they can tweak it until it actually works for the activity. They definitely took a more activity-centered approach before they got to my classroom. And when I told them this is a research conceptual based project because you're not going to get your hands on this NASA tech, they stood up straight, and then they all went white because it's not necessarily the process in which they had been exploring previously. And I got a little nervous, but then I go, no, this is good for us. This is good for them. This is good for me to push those bounds of what design can be and what it can look like, and the different types of modalities it can kind of fit into. So they were working in groups. And so, of course, there are dynamics there in group work, especially at the collegiate level, that can go all over the place, right? Like, some people really love group work, some people really despise it. But I also gave them techniques and kind of tools to work with for team management strategies. And the project was laid out in such a way that it could easily be differentiated and delineated to different team members. So it wasn't just overwhelming for one person, but also one person couldn't do the whole thing, and everybody had to carry their own weight. So that was an interesting kind of like dichotomy that occurred there, where they were learning very much team management skills and people relations between their groups. There were some issues, but I think they got smoothed out pretty quickly early on, and they really wanted to succeed. And I think that was the thing that propelled their team building activities and methodologies for completion of this gigantic project that I gave them, is that they were like, there are people here that are going to be watching us, not just me. I could tell them till I'm blue in the face, like what's important in this world, and they're going to believe me for the short amount of time that I'm in front of them. But usually when I see with students, it's like, if I'm just going to work towards getting a grade, I'm just going to work towards getting a grade, and whatever pleases you to get that grade is what I'm going to pursue. With this project, it felt different. This project was not necessarily about chasing that A. It was about, wow, we're going to be in front of NASA and this other entity. Okay, I got to actually bring it. If I'm going to say that I'm going to be doing this, I better do it. I better bring it, and I better show them what I got. And as we got closer to the presentation, I could tell that they were like, there's a little bit of anxiety kind of bubbling up to the surface. So we spent a lot of time prepping for that presentation, and I had them practicing and timing themselves. And when it came, to the shotgun of, okay, now it's, excuse me, today's the day, I walked up into our kind of class area. We're in the library for this class, and they each had their individual rooms for this presentation, because the feedback of too many computers in one room on a Zoom call is just pretty nasty. So I remember walking up there about 15 minutes early just so I could set up, and seeing students in each of these open-aired rooms or these glass rooms practicing their speeches and making sure that they had their timing down, and like giving each other mock questions. And so when they are actually presenting, I mean, they did it with such professionalism. They were all timely. They had about 10 minutes to pitch their idea that they had worked on and researched in depth over the course of the midterm onto the end of the semester. So that's about 8 weeks. And that's a lot of research, and that's a lot of ideation, and that's a lot of context to kind of squish down into 10 minutes. And so that in and of itself was a challenge for them to approach. So how they felt about it, I think they felt all the things about it at some point in the process. I think they all weren't very pleased with me for a while because of the amount of work that I had them do, the amount of in-depth kind of substantiating your claims, that they would come to me with an idea, and I'd be like, and how do you know that? Who said that? Where did you find that? And they'd be like, I'm going to get back to you on that. I'm like, okay, yes, you will. And you will get back to me cited correctly. And they did, but that's not something they were totally used to. So by the end, like I said before, I was up in our classroom, and everybody was kind of scattered around the library in their individual rooms that they had rented. And as soon as we closed out, I had like half of the students or more coming into that room going, oh, I can't believe they said that about my project. This is amazing. I want to do more with this. And they felt that sense of satisfaction at the end. And so that was where I said, okay, we're on to something. This hurt, but it was a butterfly moment. And now you kind of bloomed out, and you have that propulsion forward into kind of continuing on. I've been reading their self-reflections from this project and from the class in general, and a few of them had said like, hey, I've never thought of design in this way. I've always kind of just like hit the ground running, found the problem, found the solution, and just prototyped it. And this has started me thinking about observing more and doing more of an ethnographic approach to design, and understanding the human, and understanding the activity, and understanding function, and all of these other ideas that we had talked about in class, and then the texts that we had read. And many of them gave examples of how they're implementing it into their other studio classes that they have, and how it's kind of pushed them beyond where they felt comfortable, and now they're implementing these ideas elsewhere. And that's really the true sign of I think a good class. and of pure learning and application. And it wasn't there. This class wasn't formulated, and these projects aren't formulated to chase that grade, but to learn something and to have context for that thing, and then to take that and to apply it down the line. That to me is success. And so I feel really good about it, and I'm really happy we did it. And I'm going to probably tweak a couple of things so I don't cause as much undue stress as I probably did, but to push it a little bit further into the next kind of iteration of this class. So I take the same approach with my teaching and my classes as I do when I teach this design thinking classes. It's an iterative approach. It's non-linear, and we can always improve, and we can always learn something as we continue to kind of tinker around with the design.
That's great. Kris, I'm going to put you on the spot a little bit. Which projects really stuck out to you? Or are there any that really jumped out at you? I think we should highlight a couple of them for sure. I think they were all incredible in their professionalism and the concept and the application of the material, but are there any that really jumped out to you or you particularly enjoyed?
Yeah, I mean, Chase, they were all wonderful, honestly. I mean, I was just blown away by the professionalism, the creativity, just the inspiring products that they were coming up with based on some NASA technology. There were a few that stood out to me. And it wasn't because they were necessarily better than anyone else. It was just maybe that product or that particular solution that they were solving was more akin to something I was interested in personally, right? And so I know the group that was doing the skid plates for off-road vehicles, I've got a Toyota 4Runner, I get it, right? And so I'm like, yeah, this is some really cool stuff. But the other part that really stuck with me on that particular project was, and I want to really hit this point quite clearly, is it's not just about taking NASA technology and doing these cool creative product design activities, but it's where those products couldn't go, right? And it's not just a consumer market. So when I saw the skid plate ideas, I'm thinking about, wow, you're talking about rough terrain, harsh environments, you don't want to get stuck. What comes to my mind from a space application is astronauts in a lunar rover, right? So if you've got students looking at innovative materials to employ for skid plates, and undercarriages of off-road vehicles, there's potentially a direct application back to the space program for that type of project to engage with, either folks at JPL doing planetary rovers going to Mars or the human spaceflight side. You don't want to get stuck on the moon, right? And so that type of innovation and product caught my attention for those reasons, right? The personal side of it, but then also that spin back to NASA of thinking around like, wow, okay, this would be an opportunity where if that design progressed, there might be some benefit of trying to find some of the rover designers at NASA to come in and just have a phone call with those students and just talk about applicability for space-based rovers or planetary rovers. So that one stuck out to me. Plus, it was really great, and the team did a great job with it. The folks doing the Robo Glove design, right? The kind of grip assist kind of technology for climbing gloves and other things. I thought, wow, what a creative way to take another space-based technology and use it in multiple products, right? And really look at the physiology from a human perspective, what's going on in the hand, what's going on with fatigue and the capillary action of the blood vessels and all that type of stuff in cold temperatures. And I thought this was a very thoughtful approach to solving a real world need. And they didn't just take the technology as is, they were redesigning it and getting rid of, a couple of the motors and changing things up. So I thought that was a very inventive, creative thing to do with that particular technology. And again, I think there's this broad application for that product out in the world. And so I was really inspired by that. And then the biofeedback technology for running performance just blew me away. I mean, one, it was just incredible design, and I was like, this is really great concept work. I loved the creativity of the design itself, but it was a little bit different than some of the other teams. It was looking at kind of that software algorithm, sensor feedback loop, which is, I think, a big challenge depending on where the students are coming from with their technical background. And so to dig in on that sensor technology and the algorithms and look at it from a particular sports performance, individual performance, for something like running, I thought was incredible, right? I just was like, yes, I could see there's a huge market for a product like this. And the fact that it's based on some NASA tech is even cooler, right? And then the ability to spread beyond to other sports. And so that one really stuck with me. I still would love to see that one out on the market. I'd go get it myself. So that was really cool. So that was just a few, but again, that's not to say that any of the other ones were lesser than any of those. Those were just the three that stuck out to me for those reasons. But overall, I mean, huge win by the teams. I thought, I mean, just a great amount of work and effort, and it showed in the presentations. Like I said, very professional, fantastic job by every one of them.
I'm curious, where do you both want to see this partnership go in the future? Where do you see the potential of this? I know that we would love to do something again. I think there's plenty of opportunity and plenty of materials to experiment with in the future as well. But what does the future of this type of partnership look like, or what do you both or where do you hope to see it goes? Julie, or you want to start?
Go ahead, Julie.
Okay. So I thought it was really neat that students had this ability to kind of realize that NASA is accessible. One of my teams was working with a self-healing or punctured polymer. I don't know if I said that correctly. If you puncture something, it has a polymer inside and then it self-heals over time. And they were having a really hard time kind of wrapping their heads around, like, how does this work? Where would this be applicable? What does it weigh? What are all these things, all these questions? I'm like, I don't know. Let me find out for you. And I contacted Kris with their list of questions. He goes, why don't we just get you in contact with the inventor? And so I connected these students with the inventor, and they had a full-on couple-hour interaction with this inventor who told them all the things and then some that they needed to know about this NASA material and how they could implement it into their design and what it would mean for their product, which I thought was really awesome. So more of that connection with like the inventor and to understand, so they have a real person they can ask these real questions to instead of digging through, with their dictionary open next to the patent so they can understand all that jargon within that text. I loved that, and I'd like to see more of it. I would love to, actually get my hands on some of these products so they can, prototype and test out. I don't know how feasible that actually is. And then, maybe dig into some of these kind of grant opportunities that you had mentioned before, and like connecting these students that have these standout projects to these other kind of opportunities, to talk to more people at NASA, to maybe visit and see where your testing facilities are so that they understand like the process of testing these prototypes. I could see this branching out into a really beautiful tree that can really climb to some really amazing heights. And I think that the opportunities are there and are endless. We just have to make those dots and connections.
That's great. Kris, thoughts there?
Everything Julie said, and yeah, and then some. Well, I think there's a lot of opportunity to have some guest speakers. We've talked about a little while ago, and just getting some of the folks from like the Johnson Soft Goods Lab, where we stitch up the materials for EVA suits, and maybe some of the tool developers, right? As I mentioned before, going back to the moon, we're going to have to go develop hand tools literally for the astronauts to use on the lunar surface. And what does that look like? So in a way, not just sharing technology, but sharing design experience and perhaps methodologies about designing for harsh environments. What is it like to design a pickaxe for a ungloved hand versus a gloved hand, right? And you've got to protect the human inside the suit, but you also have to have that dexterity and mobility so that they can use the tools, and that adds a level of complexity to the design of the ultimate, product or tool. And so getting to share some more of that, I think, would be just a great bonus for you all. And I think in a similar format to this, have it recorded so you could continue to reuse those materials. I love the idea about getting some of the students, to NASA facilities and let them see how things would be tested. wind tunnels and ice labs and different things to really look at, hey, here's how we test, aircraft wings, or here's how we test EVA suits. And yeah, it may look completely foreign and alien to what you would, test for an outdoor backpack per se, but the methodologies are similar, right? And so sharing those types of experiences, I think would be great. But yeah, more technology, different applications, just broadening that portfolio and that funnel of things. And then the grant opportunities, if we can find researchers who want to collaborate with the students or with Utah State on maturing some of the technologies or particular products. Internship opportunities would be great for students who are interested, right? I know it may be out of left field for some of them if they went into the program thinking their career was going to go one direction, and then, hey, there's an opportunity to perhaps intern with NASA, and what do you think about that? And so, I'd like to mature some of those concepts and abilities to do that. And I think this first semester was a great run at what this could look like, and we'll just keep building off of that because I think the potential is there, right? And the programs from the NASA side are there. It's just a matter of stitching everything together.
No, that's great. I agree. There's a lot to come in the future, a lot of opportunity. But I guess any parting thoughts from both of you as we kind of wrap up the conversation? I know from my perspective, I wasn't a participant, but I was observing, and it was incredible to see the students work on the projects and get the chance to work with you, Kris, and participate a little bit in integrating this. It was just amazing to see the results. So I'm excited to do it all again at the next design thinking class. But any parting thoughts from you on just the experience overall?
Overall, great experience. I love the program. I love what y'all are doing there. It's fantastic. I think I've said to you both before, if I was 20 years younger, I'd be there signing up to go through the program myself. I mean, it was just incredibly inspiring, and just seemingly a fantastic program. I got to visit with you all a little bit in September and tour some of the facilities, and it's inspiring. It's an incredible thing that y'all are doing there, and I'd love to see you taking it to that next level with some NASA technology and really challenging the students, because that's what it's all about. It's a safe space to be challenged and to struggle a little bit. Their job's not on the line, right? They're not going to get fired. Yeah, the grade may be harder, but what a great place to explore and to learn and to grow. So I'm just grateful for the opportunity you all are bringing to the students, but love what you're doing. Love to continue participating, continue to have NASA engage in what you're doing, and if we can add any value to it, we will certainly do that.
Julie, parting thoughts?
Oh, I just thought it was a great implementation of this class and using like the nice trifecta of industry, of the university, and of NASA to solve these problems, these design problems, and to really propel innovation in its truest sense forward. And I am very excited to see what these students are going to do in their future now that the seed has been planted. And I just want to continue to kind of, tinker with this class and like the methods in which we kind of go about doing these projects, and to keep growing it and to keep finding opportunities for growth and for movement forward. So I'm just very pleased. Everybody, they all passed. So like everyone did great. And I'm just very, very excited to kind of continue with this relationship and to see where we can kind of push some of these other projects that were standouts a little bit further, and to see how they kind of function in the world. So
Amazing.
thank you.
Kris, how do people stay in touch with the commercialization team? What's the best way to, you mentioned a link earlier in the episode, but if people want to look at the portfolio of technologies or connect with the tech transfer team, how would they do that?
Yeah, so I did mention the links at technology.nasa.gov is a great place to just go cruise around the portfolio of technology and software. If you're interested in other cool spin-off stories or success stories of people who have taken a NASA tech and turned it into a commercial product or service, there's spinoff.nasa.gov. And so those are just some free resources, has a bunch of cool content. But staying connected with myself or other points of contact that I've introduced you all to with NASA and the tech transfer offices, actually the technology.nasa.gov website, there's a contact us link there that shows all of myself and my equivalents from around the agency and contact information. So if anybody knows about a technology at a different center that they want to go engage with and it's not at Johnson Space Center, you can reach out directly to them. But the easiest thing to do is stay in touch with me, stay in touch with my folks at Johnson Space Center, and just maintain that relationship, stay connected, ask questions. Probably we should set up like a monthly or quarterly tag just to make sure we're helping move things forward depending on your course schedule and how things look for you all in the future. But yeah, just stay plugged in. So you've already done the hard part, which is got a NASA contact, right? You're already got the point of contact. You've got a semester under your belt now using some NASA technology. The rest of it is just kind of easy moving forward, I think. So
Well, that's great. Well, it's been amazing to see, and looking forward to more partnerships in the future. So thank you both for taking the time to share a little bit about your experience. This is awesome.